Myself, Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about direct memory access. At the end of this video, the student will gain knowledge regarding what are the modes of data transfer, what is DMA, direct mode of data transfer, and what are DMA control, and what is the advantages and disadvantages of DMA control, what is IOP. So the topics that will be discussed in this video are introduction, DMA, DMA controller, and IOP. So here IO module is the basic module which is responsible for the input-output transfer. Various peripheral devices are connected to the computer. Generally, they can provide machine-to-man interaction and man-to-machine interaction. So, to perform the required functionality with the program, the needed data can be supplied with the input devices, and whatever the processing results that is produced by the computer can be represented in a user understandable form with the output devices. Both the devices together can be referred as peripheral devices. So the method that is used to transfer information between internal storage and external IO devices is known as IO interface. From the input devices, the data can be accepted and can be written into the memory, and the results that are produced as a result of processing that are stored in the internal storage memory. Those results can be fetched and can be represented in an user understandable form using output device. So, from the internal storage and external IO devices, the data or transformation of information can be take place with the help of the IO interface. So the CPU is interfaced using special communication links. So these special communication links can be used to resolve various problems that can be incurred between the peripheral devices and the internal components of the computer. So here the major problem is the peripheral devices are electromagnetic or electromechanical devices, but internal storage can be the electronic component. So to mitigate this mismatch and the speed of data transfer of peripheral devices and the CPU, the synchronization of speeds can be achieved with the help of these communication links and with a input-output interface. So, there exists a special hardware component between CPU and peripheral to supervise and synchronize all input-output transfers that are called the interface unit. Each peripheral device that is connected to the CPU can have an interface. So this is the IO module. So with the help of this IO logic, the data transfer can be moved between the data register. So what is the data that can be written into the internal memory from the external peripheral devices, first transmitted to the data register. From there it can transmitted to the internal memory. So how much data that can be transmitted, whether the data transmission is completed or not, can be tested by using the status or control register. So various flags are set whenever the data transfer can be completed, and with the help of data, status and control signal, what operation to be performed, whether the read operation or write operation can be indicated with the help of the control signal. With these signals, the peripheral devices can give input to the can communicate with the internal parts of the computer. So here the IO module can majorly take the decisions regarding how whether to display or hide the device properties, how to support whether it is a single bus organization or multiple bus organization. So here the communication path from the functional units can be achieved with the help of buses. If a single bus organization can be used to connect the devices, then the load for that bus can be increased so that the performance can be decreased. So multiple buses can be installed, organization is useful to increase the performance as well as throughput of the computer. So control device functions are leave for the CPU, and also operating system decisions. So all these decisions has to be taken care by IO module. So depending upon the operating system, the peripheral devices can be considered. For example, in a Linux or Unix operating system, the devices can be treated as a files. So to support these, the IO module can be coordinated with the operating system decisions also. So with the help of these control signals, data, status and control signals, the data transfer from the peripheral devices to the memory or internal part of the memory to the external environment can be caused. But what are the modes of this transfer? So the binary information that is received from an external device is usually stored in the memory unit. The information that is transferred from CPU to external devices is originated from the memory unit. So these are the to support the read and write operations. So the CPU merely process the information, but the source and target can be the internal storage, that is the memory unit. So data transfer between CPU and IO devices may be done different modes. There are 3 different modes of data transfer can be possible. One is the programmed IO. Second one is interrupt initiated IO. Third one is direct memory access, in short that can be referred as DMA. What is programmed IO? So with the help of program instruction, the input-output operation can be take place. So this programmed IO is as a result of IO instruction that is written in the computer program. Each and every software can support a certain set of IO instructions to facilitate the input and output operation. For example, if you consider the C software, the printf and scanf functions can be used for the purpose of output and input operations respectively. So whenever these input-output functions or instructions are found in the program, so by using with the help of these instructions, the data transfer can be take place. Those can be referred as programmed IO. So each data item transfer is initiated by an instruction in the program, and usually the transfer is from the CPU register and the memory. So here in this method of data transfer, a constant monitoring of the CPU can be required over the peripheral devices, whether data is available in the data register or not. Then only the data transfer can be take place. So most of the CPU time can be idle to perform this task. So to overcome this problem, the second method, interrupt initiated IO, can be used. So here in the interrupt initiated IO, with the help of interrupt signal, the peripheral devices can take the CPU control for the IO transfer. So interrupt is the special signal that can be raised by the peripheral devices to the CPU to indicate that they require the service of input and output. So by using interrupt facility and special commands to inform the interface to issue an interrupt request signal whenever data is available from any device on the data register. So in the meantime, the CPU can proceed with the other task execution so that the CPU idle time is greatly reduced with the help of this interrupt initiated IO. So upon detection of external interrupt signal, the CPU stops momentarily the task that is currently executing and branches to the service program to process the IO transfer. As soon as the IO transfer is completed, the CPU resumes the previous task to complete its execution. So this method of IO transfer is generally referred as interrupt initiated IO. And the third method of data transfer is DMA, direct memory access. As the name implies that from the peripheral devices to the memory, the data transfer can be take place by mitigating the CPU intervention during the input-output data transfer. So the data transfer between a fast storage media such as magnetic disk and memory unit is limited by the speed of the CPU. So to mitigate this, the devices can allow directly communicate with each other using the memory buses and removing the intervention of the CPU. That's why the direct memory access method can be used. The name can also be implied for this purpose only. So this type of data transfer technique is known as direct memory access. During DMA, the CPU is idle and it has no control over the memory buses. So directly the peripheral devices can communicate with the internal storage without interacting with the CPU. So this method of data transfer is known as direct memory access. So to achieve this data transfer, DMA module can be required. So when large volume of data are to be moved, a more efficient technique is required, that is the DMA. When voluminous data has to be transferred, the DMA can be used. DMA involves an additional module on the system bus that is called the DMA module. To facilitate DMA transfer, DMA module can be required. The DMA module transfer data to and from memory over the system bus. The DMA module must use bus only when the processor does not need it, or it must force the processor to suspend the operation temporarily. So the CPU idle time can be used by the DMA module for the data transfer, or if sometimes the current task execution of CPU can be suspended temporarily and the IO transfer can be take place. So to grab the attention of the CPU, some special control signals can be used by the DMA module. So during DMA transfer, the CPU is idle and has no control of the memory buses. So the DMA controller takes over the buses to manage the transfer of the memory buses. How these buses can has to take the attention of CPU can be by using two control lines. One is bus request, second one is bus grant. What is bus DMA controller and how the control signals can be used for the CPU? So this is the CPU and which is having two special control signals, that is bus request, which can be designated with BR, and the second one is bus grant, can be designated with BC. So the peripheral that require attention of the CPU and to access the directly the memory without the involvement of CPU can raise a bus request signal to the CPU. So after, as soon as it observe the bus request signal, it has to keep the remaining lines in an high impedance state. So a open circuit can has to be formed, and which can be removed or disabled from the external circuit, the CPU. And after putting the circuit in the high impedance state, it can send a bus grant signal to the peripheral to communicate directly the input output data to the memory. And here generally the data transfer can require the address bus, data bus, which has to access the memory with the help of address bus location, and what data to be carried can be carried to with the help of data bus, and whether what operation to be performed, read can be designated with RD and write operation can be designated with WR. So what is bus request? The bus request input is used by the DMA controller to request the processor to relinquish control of the buses. So whenever the bus request can be received by the CPU, it has to put the circuit in the high impedance state, and it can disconnect from the external circuit. So when the input is active, the CPU terminates the execution of the current instruction and places the address bus, data bus and read-write lines to the high impedance state. As soon as the bus request signal can be received from the DMA controller, so the peripheral required want to communicate the internal memory directly, so that the CPU can suspend the current execution task and keep address bus, data bus, read, write signals in a high impedance state, so that it can relinquish from the memory, and it can take over the control of the buses. So the high impedance state behave like an open circuit. So this is the first control signal used by the DMA controller is the bus request, and the second control signal is the bus grant. The CPU activates the bus grant output to inform the external DMA controller that the buses are in high impedance state. So it can indicate the DMA controller to perform the direct memory transfer of input output data from peripheral devices to the internal memory. The DMA that originates the bus request can now take the control of the buses to conduct memory transfer without processor intervention. So now the DMA can take the control of the address, data bus and read-write control lines, and can involve the directly the input-output transfer from peripheral devices to the memory without intervention of the CPU. So when DMA terminates the transfer, it disables the bus request time. So the bus request can be disabled so that it can indicate the CPU that the input-output data transfer can be completed with the help of DMA controller. So that is CPU disable the bus grant, takes control of the buses and return to the normal operation. Then the CPU can take the address, data bus, read-write controls and can resume to the normal operation and can resume the task that is suspended previously before transmitting to the DMA controller. So in this way, the bus grant control signal can be used by the DMA. So here Uh, During DMA data transfer, there are three methods of data transfer. One is burst mode, second one cycle stealing mode, third one transparent mode. What is burst mode? In this mode, DMA hand over the buses to CPU only after completion of whole data transfer. So whatever amount of data that can be transmitted from peripheral devices to the internal memory, when it is completed, then only the DMA controller can hand over the buses to the CPU. If the CPU requires the bus, it has to stay idle and wait for data transfer. So, the CPU can be again moved to the idle state, and it has to, if it requires the buses, the CPU can be in the wait state and remains idle during for this until end of the DMA data transfer completed. So that type of data transfer mode is the burst mode. Next, the second method is cycle stealing mode. So in this mode, DMA gives control of buses to the CPU after transfer of every byte. So byte by byte transfer can have to be taken place in case of cycle stealing mode. After transmitting one byte from the peripheral to the memory, the bus control can be given to the CPU. It continually issues a request for bus control, makes the transfer of one byte and returns the bus. By this, CPU does not have to wait for a long time if it need a bus for higher priority task. So, here if CPU is busy with in executing the higher priority task, if the control is taken by the DMA, the CPU can be idle and can wait for the DMA to release the buses. So this waiting time can be very high in case of burst mode. Why? Because until completion of data transfer, the burst mode should not release the DMA buses. So that if at all CPU want to execute an high priority task, can has to wait for the buses. But in case of cycle stealing mode, byte by byte, one byte transfer after the DMA release the bus, so that the CPU can execute the high priority task. But here the DMA controller can has to frequently request bus request to the CPU to gain the bus's control again. Next method is transparent mode. Here DMA transfer data only when CPU is executing the instruction which does not require the use of buses. So the CPU idle time can be used efficiently in case of transparent mode. Whenever CPU is idle, then only the DMA can take the control of the buses and can involve in the data transfer. So that type of data transfer mode is the transparent mode. So by using these three modes, the DMA can transfer the input-output data to the internal parts of the computer or the memory without intervention of the CPU. Whenever the DMA controller needs the data transfer, it has to place a bus request signal to the CPU BR signal, so that the CPU can understand that DMA requires the address data read-write control lines, so that it can put these lines in an high impedance state. So, which in turn relinquishes the CPU from these lines. So that, and it can also enable the bus grant signal, so that the DMA can understand that the buses are free and can take the control over the buses and can involve in the transfer of the DMA. So it can use three modes of transfer, that is burst mode, cycle stealing mode and transparent mode to transfer the data. So here 3 registers are used by the DMA controller. One is address register, second one is word count register, third one is control register. Address register contains the address to specify the desired location of the memory. Word count register contains number of words to be transmitted. So how the DMA can understand that the data transfer is completed depending upon this word count register, and which is specifically important in case of the cycle stealing mode. Why? Because there one byte after uh, 1 byte data transfer completion after, the DMA has to release the buses. So with the help of word count register, the word count register can maintain number of words to be transferred so that the status of data transfer can be identified by the DMA. The next register is the control register. So control register specifies the transfer mode, whether the read operation or write operation to be performed. So with the help of these 3 registers, the DMA input-output operation can be take place. So this is the DMA controller. So here we are having various control signals for the DMA controller. So here this is the data bus buffer which can involve the data to be transmitted. And here the address register, control register, word count register, these 3 registers can be connected with the controller with the help of system internal bus. And here this is the address bus buffer. And by using this bus request and bus grant signal, the DMA can activate the DMA mode of IO transfer. And here the register select control line and also DMA select control line, read, write, bus request, bus grant, these signals can be used by the DMA. And in case of interrupt initiated IO, the peripheral that requires the input-output operation can raise the interrupt so that the DMA controller can identify that the peripheral requires the IO service, which can in turn issues the bus request to the CPU so that it can grab the attention of the CPU and can involve in the direct IO data transfer between peripheral devices and the memory. So in this way, the DMA controller can use the control signals and the registers which involves the data transfer directly from the peripherals to internal storage without intervention of the CPU. So the CPU initializes the DMA by sending given information through the data bus. So whatever data that is there, that can be stored in the data register. The starting address of the memory block where data is available, where data to be stored has to be decided with the help of this data register. And it also sends word count, which is the number of words in the memory block to be read and write. So the amount of data that can be used to read and write operation can be indicated by the word count register. So the control is used to define the mode of data transfer, whether it is read or write. A control to begin the DMA transfer. So this is the DMA transfer. Here it is the DMA and this is CPU and this is the internal memory and here is the IO devices. So IO devices can has to whenever required the service, so the DMA request can has to be sent. So as soon as the DMA can require the CPU attention, it has to place the bus request signal, BR signal, so that the CPU can keep these read, write, address, data, all these in a high impedance state as soon as it receives the bus request. So that, and places this in the high impedance state and issues the bus grant signal. So by identifying the bus grant, the DMA can understand that the CPU is relinquished from the control buses, and the DMA takes the bus control and involves in the data transfer by using the address bus, data bus, read and write controls, and the data can be read and written from the RAM directly between memory and the DMA by mitigating the intervention of the CPU from the I/O devices. So, whenever this high impedance is there, the bus grant signal can be sent to the DMA so that the DMA can directly connect it to the internal memory via the peripheral data that can be taken, can be transmitted to the internal RAM. So, in this way, the DMA can transfer the input-output data to the memory. What are the advantages and disadvantages of the DMA? DMA speeds up the memory operations by bypassing the involvement of CPU. Okay. So, the load of the CPU can be greatly reduced. The idle time of the CPU can be greatly reduced. So, the idle time of the CPU can be used for the I/O transfer with the help of DMA. So, for each transfer, only few number of clock cycles are required, so that the speed of execution of the instruction can increase, so that the system performance and throughput can be increased. What are the disadvantages of this DMA? So, cache coherence problem can be seen in the DMA is used for data transfer. So, here frequently accessed data has to be stored in the cache. So, the data can be swapped to and fro from the cache memory more frequently, which can cause the cache coherence problem. Increases the price of the system by additional DMA controller as well as control lines can be installed for the DMA mode of transfer. That's why the price can be increased. So, these are the disadvantages of the DMA. Next topic is IOP, Input Output Processor. So, what is Input Output Processor? So, it is a specialized processor which loads and stores data into memory along with execution of I/O instructions. So, it acts as an interface between the system and the devices. It involves a sequence of events to execute I/O operation and store the results in the memory. So, each and every peripheral device requires the interface to synchronize the data transfer speeds between the CPU and the peripheral devices and to match the data formats between the peripherals and the CPU. So, each device, instead of installing each device with a interface, the IOP Input Output Processor can be installed to connect the all peripheral devices. So, here this is the Input Output Processor. These are with the I/O bus, all the peripheral devices can be connected to the Input Output Processor, which in turn connect to the internal parts, that is CPU and the memory unit. So, previously here we are having for each peripheral device one interface can be required. Each and every device that is connected can require the interface. So, all these clubbed together with a input output processor, and via I/O bus, all the peripheral devices can be connected to the processor. The processor executes special commands to activate the concerned peripheral devices which require the input-output data transfer. So IOP is similar to CPU except that it is designed to handle the input-output processing. So IOP can fetch and execute its own instructions. IOP instructions specifically meant for IO transfer. Only to facilitate the input-output data transfer, the special instructions can be executed by the input-output processor. In addition, IOP can perform other tasks like arithmetic, logic, branching, and code translation instructions. How the CPU and IOP can be communicated. So send instruction to test the IOP path. So first the CPU can activate the IOP operation and initiates the communication mechanism. So transfer status word to memory location. So here what is the IO transfer status? That has to be sent to the with the memory address location. If the status is okay, send start IO instruction to IOP. So then the access for the memory can be done with the IOP, conduct the IO transfer executions, and in the parallelly the CPU can continue with the other program so that the IOP can involve in the major IO transfer. And the CPU idle time can be used for execution of another task. Okay. So after completion of this, interrupt the CPU to indicate that IO transfer is completed. So that the CPU can use transfer status word to the memory location and can continue with the other tasks that has to be executed by the CPU. So in this way, the CPU and IOP can be communicated. But this is similar to the client-server communication. Whenever the IOP requires service of the CPU, it has to make a request to the CPU and can gain the IO transfer can be performed. After completion of it can acknowledge to the CPU that IO transfer can be completed so that the CPU can execute the tasks that are pending. So here the IOP can make a request and granting the services like the client server communication has to be activated between CPU and the IOP communication. What are the advantages of this IOP? The IO devices can directly access the main memory without intervention by the processor. So IO processor based systems can directly communicate with the memory and the transfer can take place to the internal storage without intervention of the memory. It is used to address the problems that arises in the direct memory access. The cache coherence can be minimized in case of the use of the IOP. So in this video, we discussed how directly from the peripheral devices the data can be transmitted to the internal storage without intervention of the CPU. One method is the DMA, direct memory access. It has to perform this task by using two control signals, bus request and bus grant. The second way is the IOP. So IOP is the processor which can execute the IO instructions. So it can request the CPU whenever it requires the service. Then the CPU grant the permission so that the IOP can transfer the input-output data to the memory without intervention of the CPU. So these are the two methods for the direct memory access by the peripheral devices. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.